So welcome to another video series. This is part 2 of two coupled universes, and we will continue on discussing how these two universes are linked together. So this slide you've seen before, except I've just rearranged it. Before I had it separated into 4 space and 4 time, so that you could see how the scalar fields and vector fields were coupled together to create one universe and then create the alternative universe. And in the previous video we talked about how the scalar fields are the primary fields and the vector fields are derived from here. So what I did is I rearranged this. So on top we have the primary scalar fields, which would be scalar time and scalar space, and at this point we understand that they are reciprocal to each other and they're coupled by scalar motion. And then from these scalar fields, the secondary vector fields are derived. So we use the gradient and divergent operations to go from scalar to vector. So in that case, you'd use the gradient to go from scalar to vector, and you'd use the divergence to go from vector to scalar. And the link, you can see that scalar time is in green. Scalar time in the top left is green, and vector space in the bottom right is green, and these two are coupled to create motion in 4 space. So now in the slide from the previous one, we had seen that these two were linked together and the reciprocity was between scalar time and scalar space going diagonally. Here we see that the diagonal is linking these two components of our space-time, vector space and scalar time, to create our universe that we're familiar with, and then the other side would be vector time and scalar space, which would create this alternative coupled universe. But it's very clear by these diagrams, whether you look at the previous one or this one, that these are tightly coupled universes, and it's motion that couples them together, and basically everything in our universe is in motion. So how do we detect matter? So basically it's the emission of photons from matter, because photons are the carrier of force fields, and as we talked about before, it's mainly the interaction of fields that we get the sensation of touch or detection. So the emission of photons is what we use to detect or feel matter, and I've put this in a number of ways. 1, the way we see it. 2, the way we can touch it and experience matter. And 3 is when we use equipment to actually detect what's going on within matter. If there is no photons, then we're not able to see matter, we're not able to touch matter or feel it, and we're not able to detect it. So these photons carry the information of the state of matter. And as you can imagine, at any particular point in time, let's say at T1, the photons emitting from here reflect the state of matter at that time in T1, and at another short time right after that, at T2, the photons then would be emitted and would have the information of what the state of matter was at T2. How matter is changed. So in the left-hand side, let's start with a piece of matter, and let's assume that the photon has not interacted with this piece of matter. And Bearden would call this mass. So it's undetectable because we have no way of touching it, seeing it, or detecting it. A photon comes along and interacts with this particular piece of matter. This photon would then represent a quantum of change. And if this photon was in the thermal part of the electromagnetic spectrum, then when this was absorbed by the mass, it would generate an increase in temperature of the mass. And now the mass is in the middle state, which is called mass time. If this photon was in the light portion of the electromagnetic spectrum, then if the energy of the photon is high enough, it would dislodge electrons in the material and create charge or a current. This piece of matter has been transformed either in subtle or significant ways by these photons that come from different parts of the electromagnetic spectrum. And Bearden calls this state of matter mass time because the matter has absorbed a quantum of change and it is now changed in its form. And in step 3, this piece of matter would then emit photons, and the emitted photons would reflect what's happened in this matter. And as I'd mentioned before, if the photon was in the thermal spectrum, then the temperature would increase, and if it was, say, in the high energy light part of the spectrum, then we would measure an electric charge or an electric current in this matter. What this does is it shows you that matter, with the absorption and the emission of photons, is continually changing between one form of mass and another form of mass time. So you go from mass, then it absorbs a photon, it becomes mass time, it emits the photon, it goes back to being mass, and then it absorbs the next photon. Now, obviously, this is being done at an extremely fast rate, but we try to use a single photon to kind of elucidate that our matter is oscillating between two states, between a static state called mass and a dynamic mass-time state. And this is how we experience the persistent flow of time in the forward direction. So now let's take this concept of an oscillating universe and go back to the diagram that is becoming familiar, where we have the oscillating universe between the now, a quantum of change, and the next moment of now. And just as a reminder, you can only cognize what you can detect. So if there are no photons, there are no signals for our eyes to respond to, our nervous system, our skin, our ears, and they all generate electrical signals which get interpreted by the brain to be experiences of the world around us. And so at the bottom we see mass oscillating between emitting a photon, and we detect that as a moment of now, and then the mass becomes invisible right after it's emitted this photon, and then there's an opportunity to absorb a photon, a change happens, and then a new photon is released, and we get to the next moment of now. And to recognize that our matter, our biological matter, is made up of these atomic structures which are going through these oscillations of absorbing photons, being changed, and then emitting photons. And when we detect this emitted photons, we really are detecting the past, because matter is going through this oscillation extremely fast, and it's already absorbed and emitted some photons which are on its way to us. So we can see that all of this is sort of coupled together, and as mentioned before with the movie example, is that since we can only cognize what we detect, we would never know what is happening in the period where there were no fields or no photons to detect. And our brain, the matter in our brain would be oscillating, so it would only be responding at those snippets of time where it is absorbing electrical fields, interpreting them, and then sending out sensory information that we interpret as our experience in the world. So continuing on this theme of oscillating universes, Dewey Lawson, in his reciprocal system theory, postulated that our universe, which he called time-space, and the coupled universe, he called space-time, exist at the same time. Now, just as a note, due to the confusing nature of those labels, because I typically think of space-time as being our universe and would think of time-space as being the alternative universe, I created the labels of for space and for time, which seem to make more sense for me. Now, as you can surmise so far, I believe that these universes are oscillating just like a movie oscillates between static images that are continuously capturing change. Tom Bearden, in his model of mass and mass time, state that mass and mass time exist independently, not both at the same time. Now, this oscillation could be as fast as Planck's oscillation, which would be 10 to the 43 hertz, which is just an incredible amount of oscillation. So in a billion trillionth of a second, a very small amount of time, you could still have another billion trillion opportunities for change. So there would be no opportunity. We could never detect that we are stuck in this movie matrix because we could never go fast enough to actually start to see the individual oscillations because it's happening at such an extremely fast speed. And just as a note, our eyes move approximately 200,000 times a day. In an experiment that scientists put together that compensated for the motion of a patient's eyes, the patient couldn't see anymore. So our very act of sight depends on oscillation or motion of our eyes. And the same is sense of our hearing. Our hearing depends on oscillation or motion of the medium of matter, typically air. And so we can go on. So we're very dependent on oscillation and on motion. We've talked about the oscillation between these two universes, and I've put the spreadsheet together that hopefully helps clarify how the two universes are coupled. In this table, the columns represent the two types of universes. It goes from 4-space to 4-time, back to 4-space again. So there's 3 cycles of oscillation that maybe help to understand how this all works. And then the properties of the universes. So the first one is the state, then the second one is the motion, and then is the changes that happen on the scalar portion of it, the agent of change in that universe, the dimensional change, and then what is related to the non-local or wave properties, and then the local and particle properties. So let's start at the top. We'll start with the state. So in 4-space, that's the universe that we're familiar with. So that's the observable universe. And when it oscillates into 4-time, that's the unobservable universe. And then it will flip back again to 4-space, which is observable again. The motion in 4-space is 3-dimensional space divided by scalar time. That's a motion that we're familiar with. In 4-time, it's 3-dimensional time divided by scalar space, or, the inverse of motion, scalar motion in 4-space. And then the changes from scalar to 3D. So here all of the information from scalar space, which was in the previous step not shown, is transformed into 3D space. The agent of change, here scalar time is the agent of change because, as we've talked about, without time there can be no motion in space, and so time is the agent of change. And the dimensional change, local information from 3D time, from the previous state, is now available non-locally in scalar time, and now all the change that happened in 3D time is non-local information available everywhere in scalar time. And in matter, the non-local or wave part of matter is associated with scalar time, and the local or particle nature of matter is associated with vector space. Now, when we go to 4-time, when we look at the change from scalar to 3D, here all the information from scalar time in the previous step transforms into 3-dimensional time. The agent of change is scalar space because there cannot be motion in 3D time without scalar space, the same way that there can be motion in 4-space without scalar time. And the dimensional change, local information from 3D space in the previous state is now available non-locally in scalar space, and now all the change that happened in 3D space is non-local information available everywhere in scalar space. So when you are changing objects or matter in 3D space, for instance, changing the geometry of matter in 3D space, that geometry impacts scalar space in 4-time. So geometry really does matter. And the non-local wave nature of matter in this universe is associated now with scalar space, and the local particle nature is associated with vector time. And then in the final column, we flip back to 4-space again, and here you see the transformation back again. And in the dimensional change here, we see how local information from 3D time is now available non-locally in scalar time, and now all the change that happened in 3D time is non-local information available everywhere in scalar space. So if you want to change the properties of our time, scalar space, you need to do it in the time when the universe is in, or matter is in the 4-time state, because now objects, time has 3 dimensions and you can change its properties, and then it flips into scalar time, and now it's available everywhere as scalar time, and will have a direct impact on motion, everything that happens in 4 space once that is changed. How do I visualize this coupling in matter? So we have these 2 coupled universes, 4 space and 4 time. Let's start with 4 time, the universe that's unobservable and that we have trouble detecting. We see that when the scalar space is expanding, then scalar time is contracting, and what it would do is compress matter. So if the nucleus is in 4 time, it would take all of the matter that's in the nucleus and it would compress it into smaller and smaller spaces. So this is what we would witness. This is happening from the perspective of 4 space. And this could account for why particles with the same charge are compressed into such tiny dimensions in the nucleus, where in 4 space, atomic particles with the same charge repel each other with lots of space between these 2 charges. And if we go outside of the nucleus, we now have the electrons in their shells orbiting. Here I'm just showing it in Bohr's model, but we know it's far more complicated than that with a quantum mechanical model. But let's just keep it in this easier to visualize model. So expanding scalar space makes matter distributed in more and more space in vector space, appearing less and less dense. And this could account for why 99% of the universe is empty space with no matter. So I'm not saying that the interface between 4 space and 4 time is exactly the radii of the nucleus, but I think that it's some radii from the nucleus on out to the bound up states of the electrons, not including the valence orbitals. What would happen is that this boundary of 4 time inside of 4 space would then incorporate all those electron orbital shells that are completely filled up, but would not include those that have valence electrons that can still interface with our biology and with our matter. So I hope this at least gives you a first pass of a way to visualize how these 2 universes interact. Switching to another topic, we also know that atomic particles called fermions are the building blocks of matter, and matter has a split personality. It manifests as a particle in a wave. Also, remember, fermions have 720 degrees of spin to get back to their initial state. So the question is, could this be postulated that 360 degrees of this is in 4 space and 360 degrees in 4 time? We don't know, but it's an interesting thought. In this slide, we'll talk about Dewey-Larson's definition of energy. So as I stated in a previous video, Dewey-Larson's theory defines velocity in 4 time, or inverse velocity from our perspective, as energy. And so let's look into that. In his theory, he defines this as a postulate with no derivation. And in fact, there are a number of postulates that are stated that have to be accepted as truth, and then he goes ahead and develops his model. Now, his model is self-consistent with the postulates, but to state something as important that energy is derived from or is equivalent to inverse velocity is pretty important. So if you accept that this is true and work with the equations of physics based on this, it is consistent. And let's look into it. So energy is equal to time over space, or in units of T over S. Now let's start with the famous equation. In physics, energy is equal to mass times the speed of light squared. Or to switch it around, that mass is equal to energy divided by c squared. So mass is equal to energy divided by c squared would be the equivalent of energy, which is time over space, or T divided by S, divided by S squared divided by T squared, which is c squared. And that equals T cubed divided by S cubed, or 1 over C cubed. So Larson defines mass as energy of motion in 4 time cubed. This t cubed divided by s cubed, which from our perspective would 1 over the speed of light cubed. Now what about force? Force is equal to mass times acceleration. So we just found out that based on this postulate that mass is equal to t cubed divided by s cubed, and acceleration is space divided by time squared, and this would give force is equal to time divided by space squared. Now let's check that. Energy is equal to force times distance. So if we just take what we found out to be force, which is t over s squared, and multiplied by distance, which is s, then it equals t over s, which is being defined as energy. So this works out. His postulate is self-consistent. It would be nice to understand it from a more detailed level, and maybe we will in the future, but certainly his postulate that energy is equal to time divided by space or inverse velocity works out with the equations. So the important result of this is that motion in 4 time or inverse velocity from our perspective shows up as energy in our universe of 4 space. In this slide I want to do a quick summary of the properties of 4 space and 4 time. So location in space is measured in terms of distance in units of space or s. Location in time is measured in terms of period or duration and units of time or t. So motion in space is velocity is change of location in 4 space, units of space, divided by units of time, or s divided by t. Now motion in time is inverse velocity is change of location in 4 time, which is units of time divided by units of space, or t divided by s. These units were previously defined as energy. Now acceleration in space is equal to the change in velocity, or the change in the change of location in 4 space, the units of space divided by units of time squared, or s divided by t squared. Now acceleration in 4 time is the change in the inverse velocity, or the change in the change of location in 4 time. And this would be units of time divided by units of space squared, or t divided by s squared. Now in the previous slide we defined the units of t divided by s squared as force. So here we can see where acceleration in 4 time manifests as force in 4 space. Here we're going to convert space and time using the speed of light c. If you take space and you multiply it by 1 over the speed of light, it gives you time. The units work out to be s times 1 over s t equals t. And if you want to convert time, you take time multiplied by the speed of light and you get space. And the units would be t times s divided by t equals s. Now, what about speed of light squared as a conversion? If we take velocity in space and multiply it by 1 over c squared, it's equal to 1 over velocity, or velocity in time. In units of space and time, that is s divided by t times 1 over s squared divided by t squared equals t divided by s, which is velocity in time, or as we've defined so far, energy. Now, velocity in time times c squared is velocity in space. The units for this work out to be velocity in time is t divided by s times s squared divided by t squared equals s divided by t, which is velocity in 4 space. And finally, speed of light cubed as a conversion. If we take acceleration in space and multiply it by 1 over c cubed, we get acceleration in time. The units in this work out that we have s divided by t squared multiplied by 1 divided by s cubed divided by t cubed equals t divided by s squared, which is acceleration in 4 time, or force as we have defined it before. Acceleration in time times c cubed equals acceleration in space. So acceleration in time is t divided by s squared times s cubed divided by t cubed equals s divided by t squared, which is the familiar meters per second squared, which is acceleration in force space. So you can see how you can use the speed of light in powers of 1, 2, and 3 to convert a location, velocity, and acceleration between these two coupled universes. Takeaway messages. In this video, I reiterated how in these two coupled universes of force space and for time, scalar fields are primary and the scalar field of time and scalar field of space are reciprocal. We continued the discussion behind the model of an oscillating universe. The focus here was on how information localized in 3 dimensions of a vector field becomes available everywhere when this information is transformed into a scalar field and vice versa. We also evaluated Dewey-Larson's definition of energy and force and showed how the speed of light can be used as a conversion of space to time and time to space. In the next video, the concept of the zero-point field and zero-point energy will be discussed. I hope you join me. If you want to hear more of these Matrix of Time videos, please subscribe below to be notified of new presentations. You can also go to my website, www.multidimensionaltime.com, and there you'll see that there's a book available. There's also some technical white papers, and all the links to my videos that are available on my YouTube channel can be found on my website. Okay, thank you very much.